Fellow Algebra 2 students, we are going to be covering measures of center today, Skill 4, Algebra 2 Semester 2. Make sure you have your notes out and are ready to fill them in as we go through this. So, our notes begin with an experiment. How many hours a week do high school students in our class watch Netflix or Hulu during the school year? And we'll use this data to create a sample of all the students in the state. If you are at home, I understand that you're not able to poll friends and do this while you are filling out your notes. So I took the liberty of creating a few sample notes for us. I polled 20 random kids, asked them for the hours of media, and these were the results that I got. I'm going to create two types of representation for this data. One is going to be a dot plot, and the other is a histogram. So our dot plot is going to look something like this. It is just going to be a straight line representing the number of hours that we have watched. We'll just call it number of hours. We can call it a media. Yes, work too. And then I'm just going to label this. I'm going to start at 0, and I'm going to go to the maximum, which was 25. And then I've got, let's say, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And we'll ignore how poorly spaced this is for the sake of my ego. Label all of these numbers for us real quick. Okay. And then I'm just going to go through, and every time I see a number, I'm going to put a dot where that number falls on our dot plot. So for our first number, we have 19. I'm going to say 19 is right here, so I'm going to draw a dot right there. Then 17. Then 24. And so on. So I've got 17 again. I'm going to add a dot on top of it. Then I have 22. 4. Another 22. 17 again. 23. Let's go right here. 1, 2, 11, 16, 19. Here, oh, we already had one. And 8, 25, 9, 6, 19, again, 12, and 23. So our dot plot sort of looks like this with the data that I've presented. Another way that we can do this, though, is with a histogram. And our histogram is going to look sort of, oops, gone too far. Is sort of going to look like 1/4 of our graph, right? We're going to have an x and a y-axis here, and my y-axis is going to represent frequency. And then my x-axis is going to be, again, the number of hours. Now, what differs here is going to be that I am going to label this a little bit different. I am going to label this 0 right here, 5, 10, 15, 20, and 25. Okay? Now, the way we draw our histogram, I'll actually label my frequency here. 1, 2, oh goodness. 3, 4. Let's do it this way. We're going to do, we'll do it up to 5 right here. And the way that we are going to label or fill in our data here is anyone who did 0 hours of media right here would be in this space right here, all the way up to 1, or up to 0. And then after we hit 0, everything from 0 to 5, so this is actually 0 to 5, is going to fall in this space. So we have a 1, a 2, and a 4. So I have 3 people right here. 3 people who watched between 0 and 5 hours. This is 0 to 5. Right? And this is 3. And then from here to here is going to be 5 to 10, and that is, we have a 6, an 8, and a 9. That is also going to be 3. So this is going to look very similar, but this is going to represent anywhere from 6 to 10 hours. This will be 1 to 5 because we're not counting 0. And then our next one is 10 to 15. We have 11, just 11. So it looks like our graph is down to 1 right here. Remember, this represents 11 to 15 hours. And then we have 15 to 20. 15 to 20 is where we get most of our data. We have 16, we have 3 17s, 3 19s. So we're going to be a little bit above our 5 here. We have 16, 17, 17, 17, 19, 19, 19. So that is 7 hours, or 7 people who watched between 15 and 20 hours, or 16. So we'll go up to 6, and I'll label it again 7. So we'll go up to 7 here, draw on our histogram, and this is 16 to 20 hours. And then the rest of our data is going to fall between this 20 and 25. So we have 2 22s, 2 23s, 24, and a 25. That is 6 data points. So this is 21, 20. And that is how we would create our histogram. As you can see, they represent the same data, just in different ways. Next, we're going to take this data, and our notes are going to ask us to calculate the mean and the median for this distribution. And this distribution is all of the data that we have. I managed to carry our data forward for us, so we don't have to go back and look at it on another slide. Our mean is going to be an average. We are going to add up all of our numbers. I'm just going to call them numbers. And we are going to divide that by the total number of people that we had in our survey. So what does that look like? It's going to look like 19 plus 17 plus 24 plus 17 plus 22 plus 4 plus 22 plus 17 plus 23 plus 1 plus 2 plus 11 16 plus 19 plus 8 plus 25 plus 9 plus 6 plus 19, oops, there we go, plus 23. I'm going to add all of these up, and then I'm going to divide by the total number of people that I asked. That is 20. So this is all going to be divided by just 20. And then I'll give us our average. I'll go ahead and give you guys a second to do that, and then I will fill in the answer for us. Okay, so hopefully you managed to put all of these into your calculator and come up with 304 over. That's going to give us 15.2. That's our mean, our average right here, our mean. Now to find the median, we are going to do, we're going to line up all of these numbers in order. Line up all the numbers in ascending order. And then our median is going to be the middle number in that set. So I'm going to give you guys a second to do it, and I'll show you what it looks like when I do it. So when I'm taking a data set and I create the median, I have to rearrange all these numbers in ascending order. And what I do is I literally just look at, here's 1, and then I go through my list of data and I mark it off. That way I don't mark it more than once. You can see I actually made a mistake here. I forgot that there was a 16 in our data set, so I skipped over it. But this is the significance of marking off the data as you input it, as you order it, so you don't miss a spot. So my data is now ordered from 1 to 24, 24 being the highest, 1 being the lowest. I have 20 points of information, so I'm going to go over 10 numbers. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10, there's 10 on this side and 10 on this side. The middle number is going to be 17. Either number is going to be 17. So our median for our data is 17. So now we have label. We're going to go back and we're going to label the median and the the median and the mean on our graph. So the median on ours was 17. So here is our median. Our mean was, it was 15 something. So I'm going to put our mean right here, 15.2. And on our histogram, our median was right here. Here's my handwriting. And our mean was just below it right here. Okay. So it says, which type of display would be easier to use if you had to calculate the mean and median? Well, for me personally, I think the dot plot is going to be a lot easier. And that's because it shows you all of the data. The histogram groups our data. It shows each piece of data. I do that every time. There we go. It shows us each piece of data. Whereas our histogram only shows us groups of data. It groups our data, making it harder to read. So I would say the dot plot is the better answer right here. Oh no, we forgot to add someone for our data set. They watch 60 hours of Netflix per week. They are binge watching every week. They wanted us to calculate the new mean. So what do you think is going to change more? So I'm going to let you guys take a second to try and calculate these and figure out which one will change more. Okay, so to calculate our new mean, I'm going to add those 60 hours into our old total, which was 304, but I'm also going to divide by 21 because now we have 21 points of information instead of just 20. So our average is going to change. It was 15.2. Our old was 15.2. Our new 17 and a third. So that was a change about 2 hours. The median, however, if you remember, we had 20 points of data, and in our 10th and 11th point of data, we had 17. Well, if we have 21 points, it just means that we look at the 11th number in our series. So we're going to count from 1 to 11 instead of 1 to 10, and that is also going to be 17. So our median doesn't change. Our median, does not change. So obviously our mean is going to be the one that changed more since our median did not change. So we're now to our important ideas. A couple of things that I want to caveat this with is we are not talking about one of our other common friends, our mode, which is our most often number. I can actually go back and do that really quick. Our mode is going to be our most often number, the number that appears most often. Most often. In our data set, it was 17 and 19. But we are not going to be talking about that a whole lot today, and it's also not super important right now. We are going to talk about our measures of center of important ideas, though. Things we have talked about so far. We have a mean, and our mean is our average, right? Take all the numbers, add all numbers together, and then we divide by the number of values. I'm going to actually write out numbers. So how many numbers did we have? And then we have our median, which is our middle value. And our middle value is, we're going to order all of our numbers from highest to lowest. Or, I'm sorry, lowest to highest. Lowest to highest. And then we select the middle number in that set. If there are two numbers, here's our strategy here. If there are two different numbers, if there are two middle numbers, we take their average. So for instance, if our median numbers were 17 and 19, their average would be 18. So that would be our median. One of the other things I want to talk about is the effect of those outliers that we had. So we would call an outlier that extra point that we added at the very end. That person who watched way more Netflix than anyone else that we polled, right? That is an outlier. That is something that doesn't really follow the set of data that we have given them. And we want to talk about how these affect our mean and our median, right? Outliers are, I'm going to give you an actual definition here, values that are either much smaller or larger than our other values. Let's see. So our mean, when in regards to our outliers, our mean is really greatly affected by our outliers, right? If we add one really high or really low number, our mean is going to move in their direction. It is going to be pulled by the outliers in their direction. So if I have a really small number, my mean is going to shrink, and if I have a really large number, my mean is going to grow. And then our median doesn't really care too much. It's not really affected by our outliers. It's only looking at the middle number, and it is affected much more by the number of values that we have than their size. So it's not really affected by outliers. It may even just stay the same, like ours did. And I'm sorry if my handwriting is absolutely terrible. Hopefully your notes key will be a little bit more legible. So this is what we're really talking about right now. And then if you want to add in here at the very bottom, we have our mode. Mode is the most often number. Most often. Number that occurs most often. Wow, here we go. Come on, Mr. Tasker. There you go. Number that occurs most often. So now we're going to do a couple of checks of understanding. We have a data set right here, and a curious math student wonders if the sizes of families are different for students than for teachers. She started with a random sample of 14 students and asked them how many siblings are in their family, and here are the results. It is going to ask us a couple of things. What is the mean, the median, and the mode? The highest frequency, the median number of siblings, and the number of siblings in the mean. So I'm going to give you guys a second to work on these, and then I will come back in and we will go over them. Please ignore that they're all labeled A. Okay, so let's talk through this. There are a couple of ways you can solve for the mean. One of those ways is to write down each individual value. We have 3 zeros, so 0 zeros plus 0 plus 0 plus 0. Then we have 4 ones plus 1 plus 1 plus 1 plus 1, and so on, all the way down the line. The other way that you can do this, is I can multiply these numbers by their frequency. So 0 times 3, that's going to give me 0. And I'm going to add to that. I'm going to add 1 times 4, 1 times 4, which is 4. So that's 4. And 2 times 3, and then 3 times 2, 4 times 1, and so on and so forth. And that's going to give me plus 6, plus 6, plus 4, plus 5. Okay? And that is going to be divided by, as well, 14, which is the total sample size, right? It was told to us. But you can also count the frequency. And that's going to give us 1.79 siblings. The median is going to be calculated as the 7th or 8th number because we have 14 samples. So the middle number in a size 14 is the 7th and 8th number. The 7th number is 1 and the 8th number is 2. You can tell by counting up here. 1, 2, 3, 4, 5, 6, 7 right here, and then 8. And since there's two different numbers, I'm going to find the average of them. I'm going to add them together and divide them by 2. It gives me 1.5 siblings. And then our mode right here is the highest frequency. The highest frequency is right here, 4. So what has the highest frequency? 1 sibling. So now we have our mean, our median, and our mode. She also took a random sample of 9 teachers and asked them how many siblings are in their family, and here are the results. The results are given on, as you can see, a dot plot. So to calculate the mean, we're going to add all of these numbers together. I have 2 zeros, which is 0. Oops, there we go. 2 zeros. And then I'm going to add 2 ones, which is 2. A 2, a 3, a 4, a 5, and an 8. And then I'm going to divide that by the total number that she said she asked. She asked 9, and that's going to be divided by 9. That is going to give me 2.67 siblings. The median is going to be our 4th number, or our 5th number, I'm sorry, 4 on each side. So I'm just going to count off 4. I'm going to go down this dot plot. 1, 2, 3, 4. Our 5th number is right here, so this is our median. You can count the other side too. 1, 2, 3, 4. I have 4 from each side. That's our middle number. So our median is 2 siblings. The teacher with 8 siblings actually had 16. If you were to correct this data, how would that affect our mean or median? Well, our median does not change, right? Because we still have 9 points. We didn't add a new point. We just changed our 8 to 16. So our median stays the same. And our mean is going to increase. It increases. Let's see how much it does. We're going to increase. Right? Because our mean is affected by our outliers. So what we're really going to have is, instead of 8, we're going to add 8 more to our total and then divide that. So our total before was 24. We're going to add 8 more, and then we're still going to divide by 9. That's going to give me 3.56 siblings. Next, we're going to go into some U-tries. I'm going to give you guys a second to read this and then figure it out. Okay, so looking at this data set, we have 7 pieces, 7 data, 7 dots, 1, 2, 3, 4, 5, 6, 7. That means that we're going to be looking at the 4th dot. So I'm going to cross off the first 3, and then I'm going to cross off the last 3. What we're left is 3, so our median is 3. So this question is going to This question is going to ask us what the mean average is, or the mean is of these scores, these student scores. So we're going to be required to add all of these up and then divide them by the total students. And then I'm also going to ask you to find the median score. I'm going to give you guys a second to work that out, and then you can come back. Okay, so what I decided to do was multiply each of these values, each of the scores, by the number of students who got them. So 6 people got 75, 6 people got 80, so on and so forth. And then I added those totals together to get 3,240, and then I divided by the number of students, which is 37, and that gave you my average, which is 87.6. It's actually 87.56 something, but it asks you to round to the nearest 10. The median score is going to be our 19th number because we have 37 students. We're looking at that middle student, which is the 19th student. The 19th number in our series is 85. And then on our next question, it is an SAT-based question. It says, based on the graph, in how many of the games played did the soccer team score goals equal to the median number of goals for the 29 games? So we played 29 games over here, and we want to know what our median number is and how many times did they score equal to that number. So looking at this graph, we want to find the median number of goals, and we want to see how many times that number was scored. We have 29 games, and each of these games is represented by one hash right right here, one hash or one piece, that would be one game. So the middle number for 29, it would be the 15th game. So the 15th number. We have 8 here, and then we have 9 here in ascending order. So our median is going to be somewhere in here, right? These are our first 8. These are our second 9. So we have a median number of 2 games, and how many times, or 2 goals scored in a game, and how many times did they score 2 goals? The answer is 9. So our median was 2 goals, and number of times they scored. Two goals was 9. Okay, in our other SAT practice, we have these 4 data points and an X, a variable, and it asks if the mean average, or the mean of these 5 numbers is 1600, is 1600, what is the value of X? So what we're looking for is, what does X need to be to make our average 1600? And let's take a second to think about what that looks like. Well, I know that there are, with X, 1, 2, 3, 4, 5. So all of these numbers are going to be divided by 5. And I know that they're going to be equal to 1600. Right? I know 4 of those numbers, 700 plus 1200 plus 1600 plus 2000 plus X. And that's going to give us 1600, right? So what I'm trying to do is really just a single variable equation. I'm trying to solve for X. I can add all of these numbers up and leave the X on the outside right here. Not on the outside, but what I'm going to do is I'm not going to add it. So 7, so this is going to be, oh no. I'm going to use my calculator for this. That's why they're here for, right? We have 700 plus 1200 plus 1600 plus 2000. It's going to give me 5500 plus X over 5 is equal to 1600. Now in order to solve this, all I do is multiply both sides by 5. That's going to cancel out, and that's going to give me 5500 plus X is equal to 8000. Then I'm going to subtract 5500 to get X. Oops, sorry, my 5500 is terrible. And that will give me that X is 2500. And that means that if I put X in here and solve it, my average will be 1600, which is exactly what I want. So finally, your Skill 4 IP will be in the classroom. You can print yourself off a copy and follow along in the key. If you have any questions, please feel free to email your teachers, and have a great day.